Hello, in this particular video, I will show you a couple of things. First, I will talk about how you can detrend and de-seasonalize your data using differencing. And then we will use some smoothing techniques in this particular data set. So this data set is the Amtrak passenger monthly data. This data set has two variables, the month and the ridership. You may have used this particular data set for running and actually estimating and forecasting using a regression model. But in this case, what we will do is we will use a simple differencing to detrend and de-seasonalize this data set. So before we do anything, let's go and plot the data set. I have selected the two variables and then clicked on the 2D line plot. So this is the plot where it looks like it may be an exponential trend, and then there is some seasonality into this particular data set. So one thing we can do is we can use a difference to detrend this. So a simpler form will be to do a differencing of 1. So d minus d of 1, I'll create this particular variable. I will then obviously take a lag of this data set, and then I'll click here. This is the lag, so I'll change this to a lag ridership name, and then we will do this differencing of 1. So the differencing here is your current value minus the previous value, and there you go. So if I plot this particular figure, I should be able to get a data set that is similar to, this particular. Let me just move this ridership plot. So this is a data set where it looks like the trend is gone. It's a straight line, so it's called detrending. But as you can see, there is some component of seasonality still left. So to do that, what we will do is we will use and we will do something called a differencing based on the seasonality. So in this case, this is the ridership with monthly data. And if you recall, when we did the regression, we actually created 12 dummy variables to capture the seasonality. So what we will do here is we will not create dummies, but we will do something called differencing by 12. Now we will difference this difference of one column, not the original data set. If you remember, our goal here is to obviously detrend and de-seasonalize it. So to do both, we have to do it from this particular data set. So what I will do is I will select not this. What I will do is let's make it simpler. Let's do our data set starts from February 1991. So we will start with February 1992, and I will say minus February 1991 data set. So, and then I'll just copy paste this, and this particular data set now should be without any trend and any seasonality. So as you can see, let me just make this note. This is D12. It should be called D1 and D12 because we have both in this particular column. So therefore, this is a data set where everything is gone, in the sense there is no seasonality and obviously there is no trend. Now one thing we can do is we can just plot D12 separately. and show how our data set looks like without the trend line, but with the trend, but still without the seasonality. So I'll create this new column called D12, and then what I will do is I will start from January 1992, and I will say is it's January 1992 minus January 1991, and this is our data set just with D12. So if I select and plot this particular line, this is without seasonality. But there is some level of trend still left in the data set. So to overcome or to remove this trend, we have to do another trend, D1 difference, or with a lag value, and we will get this particular column. Okay. So here is a data set. So in this case, in this particular video, I just showed you how you can use differencing to take care of the trend and the seasonality in your data set. Before we forecast using a smoothing technique, I want to mention some of the things with the differencing we have done. As you can see, these plots, the y-axis is pretty large, and that's why you can see this data set pretty scrambling near the zero line. So what's going on is when we did these differencing, it created a new column, column 161, because of the lag values. So before we do any kind of forecasting with this data set, I would like to remove this particular row, and because our data set it actually ends in March 2004, and there's nothing after that. And when you do that, you will see that the data set looks like this, because you have removed the high value in your y-axis. So this is the data set, this is the output with differencing of 1 and differencing of 12, which is supposed to remove both the trend and seasonality in the data set. And this is the data set with only seasonality removed, where we only did the D12 here, and you can see that there's some component of, there's no seasonality, but there is some change in the trend over time. So the next thing we will do is we will actually start using smoothing forecasting techniques. The things we have learned are the exponential model, the Holtz model, which in this case called double exponential, and the Winters model, which can be multiplicative, additive, or so on and so forth. So what we will do is I will show you with these three techniques using this particular data set. So before we do anything, I would like to you to just put your cursor in any of the cell with the data set, because if you don't do that, there will be problem later on when you run an XLMiner. For example, it will tell you that there are some missing values in your cell, and so on and so forth. So to avoid future pains, I would like you to kind of click on preferably a cell with values in the column B. So the next thing we will do is we will go to XLMiner platform and then click on smoothing. So as you can see, there are 4 smoothing approaches listed here. The exponential, double exponential, which is the Holtz method, and then the Winters method is also known as Holts-Winters method, with 3 approaches: multiplicative, additive, and no trend. So the first thing we will do here is the exponential model. Now remember, as we talked about in class, exponential model assumes that your data set has no trend and no seasonality, and it only estimates level and not anything else. It is an adaptive model because it assumes the value of level in the previous time period. So let's see, let's fit an exponential model. Now remember, when you think about a level, then it has to be a straight line with the same values over time. So I will show you also how to produce forecast with this particular technique. In this way, we don't have to create another video for doing forecast. So it's our smoothing, exponential smoothing. My time variable is month, and then ridership is what we are trying to predict. Now you can provide them an alpha value, whatever you want, like 0.2, 0.3 or so. And in the class we discussed that based on the alpha value, the rate of learning may change, or adaptation may change. Or which is preferable is to click on this button for optimize. In this way, the program will automatically get the best weight to get a better forecast. Now, in order to produce forecast, I'm going to click on this particular window, and then it tells me how many forecast values do you want. Now remember, this only forecasts the level, right? So let's say I want to say that I want to predict the next 12 months. Given this is the ridership for 12 months, so I'm going to say 12 in this particular window, and I'll click OK. And the program obviously runs. It creates two output spreadsheet. One is known as exponential output, and the other one is known as exponential stored. So in the exponential output, it will give you a couple of things. First, it will give you the best alpha value. So it looks like the program says that the best alpha value is 0.16. And then it's going to give you the output. So this is the fitting fitting an exponential smoothing line across a training data set, and then it will give you the forecasted values, which are these values, as you can see. Now remember, I told you at the beginning that this only predicts the level. So therefore, all the values for all the next 12 weeks, 12 time periods will be the same, which is 2066 to 2020.666. So what you can do is, in order to kind of plot the next few months, you can actually extend this particular data set to March 2005, and then we can just copy paste these values, which is the same value, which is our forecast column is this particular column. And then obviously we can plot everything, let's say, just to show you how the plot looks like when we do forecast. And then we can click draw, and this is what it looks like. So as you can see, this trend line, now this plot is very similar to the plot actually which was output of this particular program. The only difference is now I have added the forecasted values for the next 12 months. So this is the output looks like if you do an exponential smoothing. Now the next thing we will talk about, we also need to obviously look into the training error measures in this particular case. Now if you remember, what we have done here is, because I was forecasting, I did not partition the data set. Typically it is expected that you would partition the data and run each of these outputs. So in order to do the partition, what I will do is I will go back here, and then I will go to XLMiner platform, do partition for the time series, and what I will do is I will say that the time is the month and the ridership is the variable, and I'm going to automatically say I'll just specify percentage. I would expect to have 80%, let's say, in training and 20% data in the validation. Now the reason I'm doing this, even though I have run the exponential, is because let's say we want to compare the different techniques, the smoothing, the exponential, the Holt's method, the Winters method. And now we cannot really compare these methods if we just run it on the training set. We have to use a validation to compare the errors for these techniques and select the model that gives the lowest error. So therefore, we will actually rerun the exponential terms. And then we can then the exercise will be to select the best model and then predict the next 4 months with that best model. So I will just remove these two spreadsheets, and that way we don't have to kind of get confused later on. So we have this partition data, and so what I will do is we will fit or actually use 3 techniques on this validation, and we'll compare the errors. So once again, we'll go to exponential model, and we'll make sure that the worksheet is data partition TS. And in that case, I will make sure that the ridership is the selected variable. We will optimize once again. It's better to optimize. And we will say produce forecast on validation. Because once again, our goal will be to not to compare the errors for the validation data set. We'll click OK. As you can see, this is the plot for the training data set, and this is the plot for the actual value. Now the forecasted value is a level. Once again, it's a straight line, and this is around 2000, and so on. So as you can see, the forecasted values are 2024, and that is because that we are only predicting the level of the data set. As a note, please make a point that our MAP here is to 6.39. We need this MAP later on so that we can compare different models and select the best one. The alpha value is 0.2050. This is the optimized alpha value we got from the method. So the next thing we will do is fit a double exponential model. Now, double exponential model is the Holt's method, and Holt's method is nothing but the one which considers both the level and the trend. Now, before we do anything, we want to make sure that the worksheet is the data partition TS and nothing else. So once again, we will select ridership as our selected variable. Instead of putting values like 0.2 and 0.15, the values for the two constants, the alpha and the beta, let's click on the optimize. In this way, the method finds the best weights automatically. And then we will click on the produce forecast on validation. In this way, we can also plot our the forecasted values on the validation, and we'll click OK. So in this case, once again, there will be 2 plots to look for. One is this plot, which is on the training set, and this is the plot on the validation. As you can see, this plot shows an increasing trend. This is not a straight line as we got in the exponential data set. And here the value starts from 2002 and it goes up to 2232.6. Now the MAP for this particular method is 7.42, which is obviously larger than the exponential output we got. Our exponential output was 6.39. I just clicked on the spreadsheet exponential output, and the double exponential output is 7.42. And therefore, if we have to select one model between these two, we will go with the simpler one, which is your exponential model. The third thing we will do is fit a Holts-Winters approach. Once again, we'll click on the data partition, we'll go to XLMiner, click on smoothing and go to Holts-Winters. There are three approaches: multiplicative, additive, and no trend. We can use both multiplicative, additive, or trend, any three of them. But if you recall, we actually fit a multiplicative model in this data set when we ran the regression forecasting on the Amtrak data. If you recall, we use the model log of y as a function of x and the dummies. And therefore, we will kind of cheat a bit. Instead of searching for the best model among the three, we'll go with the multiplicative model. Now, if we do not have the prior information as we had in this case, we will actually fit model for both additive and multiplicative and select the one which among actually the best or the smallest error model. So in this case, we make sure that the worksheet is data partition TS. The time is the month. The ridership is your selected variable. And then instead of selecting the levels, we will just click on the optimize, and obviously this approach will automatically find the best weights for these three constants in the Holts-Winters model: the level, trend, and seasonality. Now, or the alpha, beta, gamma. Now, one thing we also have to provide information into this is your judgment on the type of seasonality we have in the data set. In this case, and also from our prior experience with regression, we assumed that there is a seasonality of 12 months, so of 12. If you recall, in our regression setting, we used 12 dummies and we selected 11 of them while modeling it. So in this case, when we set periods, instead of 1, we will put 12. And then we'll make sure that we click on produce forecast and validation, and we'll click OK. So in this case, it's interesting that the MAP is very low. It is around 2.87. So if we need to compare the Holts-Winters method with multiplicative model, the double exponential, which is the Holts method, and the exponential model, the choice is obvious. Our Holts-Winter is the winner, given that the MAP value is the lowest among the three models. The other things we have to think about is to look at the plot. Obviously the output plots looks nice. It's pretty close to each other. But this may also suggest some overfitting. So to look for the overfitting, we have this validation. And that's a big role of having a validation in our data set. Validation, and since we are comparing models on the validation data set, we are kind of avoiding models which may lead to overfitting, or we are not falling into the overfitting trap. That's what I would say. So it looks like also in the validation set, your Holts-Winters methods is the best, and as you can see, it has really the forecast is fairly close to the observed value. So, the winners among the three data sets, three approaches, is your Holts-Winters approach. So now, since we now know that Holts-Winters is the best model to go for, so let's go and predict the next 12 months of data using a Holts-Winters method. Now, as we have done in the previous approaches, when we forecast the final forecast, we do not use the partition data set. We use the original data, which includes all. Because if we use the partition data set, the approach will only look at the training data, and we will have a gap, and therefore the gap will lead to very, very bad forecasted values for the future. So in this case, we will just click on the sheet 1. That is what we're going to use for our forecast. Now, once again, we will be using a Holts-Winters multiplicative approach, and we will predict the next 12 months of data. So we will go to smoothing. We go to Holts-Winters, click on multiplicative. Now I want to make sure that our worksheet is sheet 1 and not the data partition TS. The month is a time variable. The ridership is the selected variable. Period is 12, as we have done. This is our telling the program that the seasonality is 12 in our data set. We will use the optimized values because it's better to let the program do it for you. And then we will do forecast of 12. Now there's an option says update estimate each time. Now if we do not select update estimate each time, it's not going to consider the new forecasted value to predict the next forecasted value. Now, if you remember the equations we have used in the classroom, now we have there were three equations, one for the level, one for the trend, and one for the seasonality. And in the three more equations, we know that there is a quotient of adaptation and obviously learning from the past time series. So if we do not select this, update estimates at each time, we will get one set of results. And if we select this, what the program will do is it will forecast a time point, and then it will use the new the forecasted time point value to predict the future. So that's much more practical to some sense. So we will click on this particular button and we'll click OK. So once again, our map is pretty small, as it suppose should be, and then we have the new forecasted values. This is the value what we already have with the actual data set, and as you can see, the approach, this model is pretty close to the original. So I'm going to now plot everything together. I'm going to select this forecasted values, the new forecasted 12 months values, and we'll just add to this particular column, which is the forecasted column. Let me make sure that's the case. Yes, it is. And then I'm going to just extend this particular data set from March 2000 to obviously March 2005, and I'm going to select these three columns and then plot them just to show how our approach did. Okay. And it is always good to use and select and obviously plot these figures. In this way we can learn about our approaches are good or bad. So as you can see, this is a pretty good plot showing that our actually ends here sometime in our values, and then it should end in March 2004 somewhere here. And then this part actually is predicted by the approach. And as you can see, this method actually did a very good job on capturing the trend and the seasonality over time. So once again, this is an approach showing that how you can use three different smoothing techniques, forecasting techniques: exponential, Holt's method, and Holts-Winters method to predict a time series. Thank you for listening.